The more nuggets you view about the Cisco UCS system, the more you appreciate the importance of the Fabric Interconnect. In this nugget, we're going to focus on one thing: redundancy of those Fabric Interconnects, how critically important this is, and we're going to learn all about it together in this nugget. Now, it's going to come as no surprise to you that when we implement Fabric Interconnect redundancy, we need those peers to have the same exact model and software running. So if we have the 6296 UP Fabric Interconnect right here, we're going to want the 6296 UP Fabric Interconnect for our B device. Remember, we tend to label 1A and 1B in our Fabric Interconnect infrastructure. By the way, when you do this, Cisco refers to this pairing as a Fabric Interconnect cluster. So that's the terminology they use. And the specific terminology for this concept I'm showing you here is that our cluster peers need to be identical. Now, there is one interesting exception to this. If you are wanting to upgrade one of your Fabric Interconnects so that you can have more ports, you can have the differing models during that upgrade process. Let me show you exactly what I mean. Let's say on Fabric Interconnect A, we have the 6248 UP in place. And we say, you know what, we really want to migrate to the 6296 so we can have more ports. Well, you can do that during the transition. You can go ahead and you can implement the 6296 over here. And then what you do is you take this out of production once this is implemented and you make it the 6296, and now you're off and running again with your identical peers. You could do this with the 6120. So let's say we're running a 6120 over here. We could go ahead and upgrade on the right with the 6140, then we'd go ahead, take this out of commission, and put in the 6140 over here. So there is an exception to this identical peers concept, but it is only when we are migrating to a model that has additional ports in the same exact family. Pretty cool that we have this ability, obviously, to upgrade our infrastructure. Now, in order for there to be this redundancy between our Fabric Interconnects, there needs to be an interconnect network. And that is accomplished, as I'm sure you know, by 1 gigabit per second links that we set up between our Fabric Interconnects. We use Cat6 cabling at 1 gigabit per second in order to pull that off on each of these links. We have a link 1 port, we have a link 2 port, and we connect those back to back on our Fabric Interconnects. We could certainly use one link between the two, but that would make no sense whatsoever from a redundancy perspective. So let's utilize those multiple links. What do these interfaces carry? Well, they carry what Cisco calls heartbeat messages, which are absolutely critical for the devices to see each other, as well as they carry high-level messages between the UCS manager elements. By the way, we have 2 links between our Fabric Interconnects, and whenever you see this, what do you think of? Yeah, you think of Link Aggregation Control Protocol, and that's exactly what the Fabric Interconnects will do. They will automatically form this bond of those 2 links for these important heartbeat and control messages to flow between them. Now, before we go any further, I want to make sure you're very clear on how this redundancy situation works with the Fabric Interconnects. In earlier nuggets, you've heard me talk about our active unit and our standby unit. And that is certainly true, but that is true from a management perspective. When it comes to the data plane, we are obviously in an active type of an environment for the redundancy that we want with sending data through our data center. So, yeah, sure, we're active in standby, but that is from a management control plane perspective. Keep in mind, too, that we are dealing with a floating virtual IP address, aren't we? So, we have this IP address, let's say it's 10.10.10.1 that we use for Fabric Interconnect management, and this will float, if you will, would be accessing the active device, and of course you do your management through the connection to the active device, but if it were to go away and this device were to become active from a management perspective, that IP address would float and we would go ahead and be utilizing it against that second Fabric Interconnect without really even knowing it from a pure just interface perspective. You see, in order for this to ensure that it would work well, Cisco built in something called the UCS Manager Controller application. And this particular application is responsible for ensuring that we have our active standby Fabric Interconnect for management purposes and ensuring that that synchronization goes beautifully. This particular UCS Manager Controller app runs as a separate process and is separate and distinct from other processes and is a critical component for our cluster redundancy configuration. Now, there is another key ingredient I want you to understand about the cluster in order for it to work right, and that is the fact that the Fabric Interconnects are going to utilize two types of storage. Each Fabric Interconnect, of course, has its own local storage, right? So we know Fabric Interconnect A will have its local storage. This is non-volatile RAM and flash memory. We know Fabric Interconnect B will have its local storage. But in order to really make this cluster happen, there's also needing to be storage shared by these devices that exists somewhere else. What a great place that somewhere else can be if it's down in our chassis. That's right, there is what's called chassis storage. We refer to it as shared storage for our Fabric Interconnects, and it is indeed used to help with this whole concept of a clustered approach to the Fabric Interconnects. Technically, this storage is in the form of serial EEPROM. So you'll often see this abbreviated by Cisco as CPROM. So this is our storage that is shared from a perspective of those Fabric Interconnects. Dynamic portions of this memory contain specifics that a particular node will see, and this gets obviously read from by the alternate device when necessary. So this is a shared area of storage that really facilitates this clustering effect that we get inside the UCS. Now, as you might guess, it is very easy for us to get redundancy information about our Fabric Interconnects inside the UCS Manager graphical user interface. Here we are on the Equipment tab, and I can go ahead and expand my Fabric Interconnects. Right there in the display, we're seeing that Fabric Interconnect A is primary and Fabric Interconnect B is subordinate. Remember, this is from a management plane perspective. If I go into Fabric Interconnect B, for instance, and literally select it, and then I go into its informational pane, notice we have the high availability details area. Here I can see, yes, we're in the ready state, we're in the up state, we are the subordinate, and our cluster link state is full. So we're fully converged here. Everything is great. It just so happens that we are the subordinate device. Let's go over and take a look at the primary. And again, we'll access its high availability details. We can see ready, yes, state up, leadership primary, and cluster link state full. So we are fully synchronized here in our interconnect A and B relationship. Now, what if you wanted to see this information at the command line? Well, at the command line, you would do a show cluster extended state. And this command is going to go ahead and give you the equivalent of these statuses that we can see in the graphical user interface. By the way, very simple to change these roles, and we do this at the CLI. We have the cluster lead command that you can do to make the local device take over as the primary device, and you can do the cluster force primary command. The cluster force primary will also go ahead and force this election process and potentially for you switch who is the primary device. Now, it's really appropriate that I just happen to be teaching this class on October 31st. That's Halloween here in the United States, and that is perfectly timed because we're going to talk about split brain. Yes, we get a split brain condition potentially when our links fail between the fabric interconnects. The first type of split brain condition I want to talk to you about is called a partition in space. The partition in space occurs when our nodes fail to communicate with each other over their private little network. What obviously could happen here is that we get into a situation of active and active from a management perspective. Yikes. We want active on these devices from a data perspective, but certainly not a management perspective. So what happens with the UCS system in order to resolve this partition in space split brain condition? Well, each of the devices is indeed reduced to the subordinate role, and then there is something called a quorum race. This happens inside our chassis with our particular chassis management controllers, and they are utilizing that serial EEPROM that we mentioned earlier. And long story short, thanks to the quorum race, one of these devices will be marked as the active device from a management perspective. So there is a built-in quorum race procedure that will take over when we have this split brain partition in space situation inside the UCS. Now, the other split brain condition that we can have is referred to as a partition in time. Let's say this node is booting up, and when it boots, it notices, thanks to a version number that is maintained, that it has an old copy of the UCS configuration information. So what happened was this node that is no longer there must have been there at some point and written more recent configuration changes. This one will stay in a subordinate state because it certainly doesn't want to overwrite the UCS system with its old stale information. So here's our partition in time, and again, this is to ensure that this split brain situation does not cause major problems for us in the UCS environment. Well, the last thing I need to show you here is the configuration of that floating IP address, that virtual IP address for management in our cluster. Notice where we are. We are on the admin tab in the UCS management graphical user interface, and under communication management, we are under the management interfaces node. Here we can see the management interfaces tab. Here we have our floating IP address, and then here we can see the actual IP addresses that are on Fabric Interconnect A and Fabric Interconnect B. So here we are, it's final exam time. What prompts the condition known as split brain in the Cisco UCS system? A failure of one input output module in the chassis? A failure of the private network between the fabric interconnects? A failure of the LAN on motherboard port of two different B series blades? A failure of the chassis management controller? Well, we looked at two different potential split brain conditions in this particular episode in our course, didn't we? Yeah, we took a look at what was known as the partition in space and the partition in time, didn't we? And we discovered that under the partition in space concept, we would indeed have a failure of the private network between the fabric interconnects. Awesome job. With the partition in time situation, we knew that this had to do with a particular device being in the down state, another device coming up and realizing that it had an old version of the UCS configuration information. This would be, therefore, really related to the failure of one of our fabric interconnects. The partition in space was the real point of this question, and of course, both of these refer to that concept of split brain within our UCS system. Now you know, awesome job. Excellent, excellent performance in a really relaxing and rather fun nugget. It was probably time for us to take a little bit of a break together in this course we've been working so hard. This nugget was indeed quite straightforward. But I hope you found it informative, and I want to thank you for viewing.